Hi everyone. So we have mastered the AND gate, NOT gate and different type of basic gates which are present like OR, NAND, NOR, etc. So today we are taking a massive leap forward. Okay. So we are going to build a half adder. So in this video I'm going to discuss how you can do the code for the half adder as well as half subtractor. Okay. So now what is the half adder? So before the code, let's look the logic. So half adder adds two single bits A and B in binary format like 0 plus 0 means the result will be 0, that means the sum means here two inputs are present like A and B. Let's take two inputs are present A and B and there are two outputs are present. What happens in the basic gates when we done the code, or if you have seen the physical IC, physical IC, in those IC you can get the single output only from the two input basic gates like AND gate or OR gate or something. But when you start to do the extra circuits like sequential or the combinational circuits, in that time the output may increase more than 2, more than 3 or more than that. Okay, so in this half adder, this half adder is basically nothing but a combinational circuit which consists of two inputs with two output. And what are those outputs? Sum and carry. Means if the input is present as 0 0, then in the AND gate or in the basic gates, what we are getting? A single result. Means 0 0 output is 0. 0 1 output is 0, 1 1 output is 1. I am telling for this AND gate, basic two input AND gate. Okay. Now for this half adder, we have two output, sum and carry. Now for the two input 0 0, the output will come or display in the screen not only once, it will be twice. Twice means one output for the sum and another output for the carry. So when you means if you have done the physical hardware by using the physical ICs by your hand by using breadboard wires, etc., you will already know that in the half adder two output wires will be generated, one for sum and one for carry. So here also in this code also we have to make sure that the half adder consists of two outputs, that is sum and carry. So from this only we can understand that yeah, for the sum the result will be different and for the carry the result will be different. Now for the sum, sometimes the result can be 0, sometimes the result can be 1 depending on the input signals. In the same way carry, in the carry it will also depend that whether it will be 0 or it will be 1 according to the input signals. So in this sum, means suppose, I'm not telling the suppose, think that you have taken the input or you have think that the output is the sum. Take the output as the sum. Sum in, if you see the half adder diagram or the derivation for the sum and carry, then you can find that in the sum at the end the result come out as a dash b plus a b dash. Now what is that form? That short form is a or b. A or b. For the a or b, if you expand the a or b, it will become a dash b plus a b dash. But we will take here the short form, that is a or b. That means the sum is producing the output for the result or for the gate is the XOR gate. That means the sum is producing the output as a or b. And for the carry, the carry is producing the output for a dot b, means a and b. Okay, so let's recap the introduction part, that the half adder is consist of two input a and b with two output sum and carry. Sum will produce the output as a or b and carry will produce the output as a and b. So before moving towards the code, I want to suggest once again that please go through the previous video, especially the AND gate. In that AND gate, I have explained the whole code line by line and word by word. That that video is most important video, and you must watch that at first before moving towards the remaining basic gates and remaining sequential and combination gates. I will suggest go and check the AND gate. I have already uploaded the AND gate link in the description box. You can go and check it once. In this video, in this half adder, I will also explain the code, but not that much in depth which I have done in the AND gate. Okay, so let's dive into it. Okay, before starting our code, we have to do the setup. So as all the video which I am going to upload for the EDA Playground code, means for the digital electronics code version, all of this code will be done in the VHDL. So for that reason, we have to do the setup according to the VHDL only. So for that, we have to move towards the left panel, this left side. Now open the languages and libraries part. After this, Testbench plus design. Click on this arrow and select VHDL. Okay, select the VHDL. Leave this libraries part, leave this top entity part. In the later we will use the top entity and we will know that what is the utility of the top entity. Another thing I want to suggest you, that if you don't know that how to use the EDA Playground or what are the basic things, means what are the meaning of these languages and libraries, why we are using VHDL for the Testbench plus design, means the brief explanation about the libraries, top entity, these tools and simulators. All these things I have also uploaded in a video, and that link is also present in the description box. So if you want to get a brief exploration or explanation about this EDA Playground, then you can go and then you can check it. Okay, so let's move towards the tools and simulators. In this tools and simulators, click on this select button, then click on the commercial simulators. Under that, ALDEC Riviera Pro 2023.04. Okay, then leave this compiler option, leave this run option, leave this runtime option. Next, open EPWave after run. This checkbox have to be a tick mark. Okay, because after running your code, you have to see the output, so that output will be generated in a waveform. For watching that output, you have to make sure that this checkbox has been clicked, that is open EPWave after run. Okay, open EPWave after run. So all of this process has been completed. Now let's move towards the design part and the Testbench part. Now this design part, design.vhd. This design.vhd, in this design.vhd and in this testbench.vhd, you can find a difference, that before it was different, but now the code has been changed, means a new order present or has been added, that is library IEEE. Then use IEEE.std underscore logic underscore 1164.all. Now this means that we are using the library of the IEEE package, and in that package we are specially using a special package which is present in the, or the package number is the 1164. From that package we are using all the things which are present in that package. All the things are using, or we are using in this code. That's why we have written that .all. Okay, so this explanation I have already given in the AND gate. So I will suggest that before watching this video, please go through the AND gate, and there each and every code has been explained line by line and word by word. Okay, so next we have to give an entity name. Entity name is nothing but a black box, which you can also say that if you done the programming language like Java or C or anything, there you write a class name, right? Class, then a given name, then think like that only. Here we are not writing as class, we are writing as entity. And that class also has a name. No, you give the name as class something like main, or your name, or program name, anything. So here also we will use a name, class half adder. I am using the half adder for the better understanding. If you want, you can use different name also. Okay, class half adder is. Now class half adder is means we are entering into the half adder, inside the half adder, means the black box type of thing. You know that IC has consist of outer coating, black outer coating. Outside that the IC number is present, and also some pins are present. 1 2 is input, 3 is output. Like this, you know that these pins can work like this. But in the coding also you have to give the information that okay, so for doing the code, I don't know that what is present inside the IC, but I know what is present outside the IC. What is that? Is the black coating, means where the IC number is present. That means we are giving the entity as a half adder. Then what are the ports are present? Different type of ports are present, like input, output, like this. So here also we will use the port function as port. Then open up first bracket. Then we will give the different type of ports. Here I have told that we need 2 inputs and 2 output, so that's why we will take a colon in means we are using in means it is an input. Okay, std logic, then semicolon. Again move to the next line, b colon in std logic. Okay, then next this two we have taken the 2 inputs a and b. Inputs are complete. Now we have to move towards the output. So in the for the half adder 2 outputs are present, that is sum and carry. So sum colon. For this we will not take or not write as in, because it's not a input, it's a output. So we will write as out std logic logic. Then write carry. Another output is present, carry colon out std logic. Then first bracket semicolon. Then end entity half adder semicolon. Okay, so here we have taken ports, 2 input a and b with 2 output, sum and carry. Now I have given some space, entity, then some tab space, then I have written as port, then some tab space written as a. So this tab space or this space are not mandatory. I am giving it so that you can understand much more better. Explanation, the code, the beauty of this code can also be increased. Okay, so by this you can understand that okay, under entity the port is present. Okay, then under port all the inputs are present, a b, then outputs are present. You can understand it better. Okay, suppose thing like some functions or class are using, like in the Java. Okay, as public class, then give a name, then semicolon open, then indentation, it follows the indentation, right? Under that the public static void main string args, third bracket open close args, this is present. And whenever you open the second bracket, then next line is follow the line. If you use the scanner class, then it will become a scanner s equals to new scanner system.in. So like this, a indentation followed by the Java code, but here indentation is not mandatory. You can use the tab space according to you, or no need to use any tab space. Okay, so end entity half adder is complete. Now all this word means this, what is the entity, why we are using half adder, why is what is port, what is std underscore logic. This brief explanation has already been given in the AND gate, so please go and check the AND gate first. You can understand the whole code very thoroughly. After that you can understand it, because in this video I will not explain this again and again. I have already explained in the AND gate. In this video I will only show how to do the half adder and what are the necessary steps have to be followed for doing the half adder. Okay, so this part has been completed. Now next we have to do the architecture part. Architecture part is nothing but, now we are entering inside the IC. Means suppose a physical IC is present in your hand and you have seen that what are the outer layer is present, the outer code is the black code and with some pins, means entity half adder. In the outer code IC number is present, that means entity is present, half adder, and some ports are present, some pins are present in the IC. Those pins are nothing but A, B, sum, carry. Okay, now inside that quotation, means inside that black code of the IC, millions of transistors are present, but we can't see those transistors if we do not open that box, or if we do not break it. Okay, if we break it or if we open it, then only we will see the infinite number of transistor, means million numbers of transistor or 100 number of transistor, but before that we don't know now. So for that reason, here also you have to give the internal part also. So that's why we'll use the architecture part is nothing but we are giving the internal structure for the entity, means for the outer cover is ready. Now we are giving the architecture, means now we are giving the internal part. Copper wires connection are making by through the internal through the architecture. Think like a keyboard is present, some keys are present, and a screen is present. If you do not connect the keys with screen, then output or the buttons which you are pressing in the keyboard will never display in the screen. So for that reason we need a internal structure. No, so that internal structure is nothing but architecture. Okay, so let's write the code as architecture. Okay, architecture, then you have to give a name of this architecture. I'm using a default name, that is behavioral. Okay, you can use anything, no issue, you can use anything. Behavioral, then of whose behavior, means the architecture will behave like whom, which one. If you don't give the name, then it will give a error. Okay, so you have to give the name to whom, you have to give the entity name, that is half adder. I'm giving the behavior of half adder. Okay, then you have to give is, then next line begin, again next line. Now we have to give the internal structure for the output, means how the output will generate. The sum and carry, how they will behave. They will not behave as okay, input is getting, then output is coming. The sum logic will be there. No, for the sum the logic is for the sum the logic is XOR gate, and for the carry the logic is AND gate, means sum is A XOR B. So sum equals to, here equals to is given like this, less than equals to, not normal equals to. Unlike Python or C, there we give as equals to, like A equals to 5, B equals to, means 5 has been assigned to F or B has been assigned to A. Like this, here equals to is sum less than equals to. Less than equals to means A XOR B, means we are using the sum will use, or sum will give the result as A XOR B. That's why this A XOR B has been assigned inside the sum. The output sum will give the output by doing the A XOR B, means whenever the 0 0 will be present for the sum, it will give the result as means as the XOR only, means whatever result will be come out for the XOR A XOR B, that output will be given by the sum. That means A XOR B has been assigned to the sum, inside the sum. Then carry less than equals to A and B. Carry is doing A and B. Then this is complete. Then we have to end this. Architecture have to be also end architecture. Then you have to give the name again, behavioral. Then semicolon, you have to give the semicolon. Okay, remember this. So this is the design part. The design part has been completed. We have done all the things, that library, we have taken the library, we have taken the ports, entities, we have also taken the architecture part, everything.